So there is an interesting argument to be made against certain assumptions made about the role that can be attributed to causality as an element of reality, which then give rise to a multitude of speculative proposals, such as various dependence finitist proposals that form the groundwork for various cosmological arguments. So what am I talking about? Well, if we have a certain view of causality as the ultimate fundament of concrete reality, we may accept something like dependence finitism. So, there are finitely many fundamental initial elements to every dependency chain, which roughly implies that there are no infinite backward sequences in the sum dependence relation. So, no entity, concrete, material, or otherwise, is transitively or directly dependent upon an infinitude of distinct entities. If we understand causality and especially causal dependence in such traditional ways, we may accept causal finitism as implied by dependence finitism as there are finitely many fundamental initial elements to every causal chain. Or, as Alexander Proust puts it, an infinite number of things cannot be causally prior to one thing. Let's put this in more technical terms. For any causal item X, it holds that the set of elements causally prior to X has only finitely many elements, which then in turn implies for any causal item X, it holds that the set of elements temporally prior to X has only finitely many elements. So if X is located at time t, the set of objects located at t star earlier than t is only finite. This of course only holds if we exclude retrocausality and/or temporal causal loops. The overarching intuition here is that the implications of causality and, once again, especially causal dependency, have to be seen as a global standard for a complete metaphysical picture of reality, such that we likely ought to end up with some ultimate causal origin of all concrete reality that our posterior causal instances depend upon. Cosmological arguments, whether temporally motivated as the original Kalam, or focused on sequential origins such as Aquinas' first two ways, or even contingency arguments that are more broadly focused on reasons and explanations, but really refer to causal reasons and explanations, are, as is prima facie plausible, all fundamentally depend upon the intuition that concrete reality must have a single unified global causal explanation, and is neither locally nor globally unexplained. Now, on the face of it, these intuitions and considerations seem plausible, and more interestingly, despite decades of scientifically respectable cosmological modeling, they have largely stood the test of time. Now, while it seems that past infinite cosmologies are still viable targets of intellectual enterprise, such cosmological approaches have hardly proven to be dominant or necessary, no matter how much of a desired outcome it may have been. For many people, it seems to have been an honest desire for modern physics to put to bed or at least drastically invalidate such all too dearly held metaphysical intuitions. It has been desired, it didn't really happen. But there may be an argument from physics that may really provide some evidence against the whole family of cosmological arguments that relies upon ultimate causal origins and denies the possibility of infinite backward sequences and infinite regresses. I believe there can be a neat little argument from CPT-Symetry against causal dependence finitism. In other words, I believe that modern physics can provide evidence against causal finitism. Now, what is CPT-Symetry? The way I understand it is that, given certain symmetry conditions, there can be a mirror image of a universe that in fact exactly resembles it to the point of indiscernibility. So, fact is that some universe would be indistinguishable from its counterpart if the position of every particle was changed to a position that corresponds to a reflection through a point. Each and every particle was replaced by its antimatter counterpart, and the direction of time was reversed. The three relevant symmetries can be named as charge conjugation, parity, and time reversal symmetry. So, if we mirror physical reality to some point, reverse the charge of each particle, and reverse the direction of time, we end up with a de facto identical universe, indistinguishable from the original one. Crucial is that none of these symmetries on their own suffice, so that each separate symmetry actually has its own intrinsic significance. For example, it was traditionally assumed, for example by Leibniz, that parity on its own was to yield the same result, namely an identical counterpart to a universe. And yet, the The physics of the latter half of the 20th century decisively disproved that. The interesting question was if the conjunction of charge conjugation and parity suffices for indiscernibility, yet it was experimentally proven that this is not the case. And this is important for the argument, for what this shows is that there is some intrinsic importance to the temporal order of things. Now, let us consider what time reversal symmetry is. A system encompassing a progressing temporal sequence is said to exhibit symmetry under a time reversal transformation if the order of every subset of its progressing temporal sequence may be reversed with initial and final states interchanged. Or, equivalently, symmetry between the two directions of motion in time implies that to every state C there corresponds a time-reversed counterstate C star, and that the transformation preserves the sequential identity of C and C star. So, if I have a simple time axis and we move sequentially from state A to B, then if there is some relevant counterstate to A, named A star, such that if we reverse the temporal direction, progressing from A star, we sequentially reach B star, the relevant equivalent of B. The important point of all this is that CP doesn't hold. Charge conjugation and parity alone do not yield a relevant counterpart, which in turn demands additional time reversal symmetry. Now, what am I getting at? Now, consider some universe U that is nomologically identical to a universe. Then, given CPT, there exists some mirror universe U star that is indistinguishable from U. So, following Leibniz, one may affirm the identity of indiscernibles, an ontological principle that states that objects or entities that have all their properties in common are not in fact numerically distinct. One might be hesitant to do so, but it seems at least reasonable to accept such a principle. A stronger, albeit epistemological principle, is the identity of indistinguishables. Two entities that do not have any properties allowing to distinguish them are not numerically distinct. This implies that, in the absence of any property or feature possessed by either of two supposedly distinct entities A and B, that would, even in principle, make it possible for them to be differentiated, A and B cannot in fact be two distinct objects. They have to be one and the same. This seems too strong, given what we know from CPT. Given some universe U that is nomologically identical to a universe, then, given CPT, there exists a mirror universe U star that is indistinguishable from U. Here we can, in fact, construct a counterpart of an object that is indistinguishable from the object itself, and yet obviously they are numerically distinct since, given for example charge conjugation, the two objects are composed of distinct entities, do not share each and every property. So let us be a little bit more precise and careful with our definitions. Let's define the identity of indiscernibles as if there is some object X and some set of properties S such that S contains all the properties instantiated by X, then if there is some object Y such that Y instantiates S, then X and Y are identical. For suppose for reductio that there is some property P instantiated by Y such that P is not element of S, then X wouldn't instantiate it but rather not P, but then not P would be an element of S. But Y cannot instantiate P and not P at the same time. So, given the principle, X and Y are identical. Then, analogically, consider the identity of indistinguishables. If there is some object X and some set of epistemologically relevant properties S, such that S contains all the epistemologically relevant properties instantiated by X, then if there is some object Y such that Y instantiates S, then X equals Y. Reductio may proceed as mentioned above. Now, while we may affirm the identity of indiscernibles, we, given CPT, must reject the identity of indistinguishables. But there is a kind of middleman, a plausible metaphysical principle that can be affirmed given the affirmation of the former and the rejection of the latter. Let's call it the possibility of an indistinguishable. If there is some metaphysically possible object X and some set of epistemologically relevant properties S such that S contains all the epistemologically relevant properties instantiated by X, then if there is some object Y such that Y instantiates S, then Y is metaphysically possible. So, just to be a little clearer, Since our relevant counterpart universe U star instantiates all the relevant properties that make it de facto indistinguishable from, say, our universe U, then, since there is no possible physical experiment we could run to find out if we happen to reside in U or U star, we should conclude that, in the absence of any reason to suppose the contrary, U star as well as U is metaphysically possible. But if our counterpart universe U star is equally metaphysically possible, and U star has a reversed temporal axis, then this means that the temporal causal order is reversed as well. Causal item X then depends upon the set of causal items for each of which it holds that they are located at some time t star later than t. But our definition of temporal causal finitism stated, for any causal item X, it holds that the set of elements temporally prior to X has only finitely many elements, so that if X is located at time t, the set of objects located at t star earlier than t is only finite. But for U star, our counterpart universe, the reverse must hold. For any causal item X, it holds that the set of elements temporally posterior to X is only finitely many elements, so that if X is located at time t, the set of objects located at t star larger than t is only finite. So far so good, but current cosmology strongly implies that the future is potentially infinite, and as far as I know, there are no cosmological models that demand for there to be some necessary future time boundary. But then, if TCF and TCF star both hold, there are past as well as future dependency commitments which run contrary to current cosmology. And then, given the state of current physics, we may conclude that causal finitism is false. But it's even worse. Given the metaphysical possibility of U star and the implication of a possible indistinguishable time-reversed universe, causal finitist dependency commitments stretch both ways and ontologically anchor every temporal state from past as well as future states. Funnily enough, we could also plausibly claim that, for any state or causal item, either TCF or TCF star must hold, so that, for any causal item X, it holds that the set of elements temporally prior to X, or the set of elements temporally posterior to X is only finitely many elements.